So I've upgraded the electronics in my kiln. I'm going to call it a kiln now because it's much more fun to say and more accurate, and it won't get Americans confused about the furnace for heating my house, which I don't have because I live in Australia here in Queensland. It's quite warm. Anyway, so I've introduced a relay over here. This is a big chunky 30 amp 240 volt relay because I was having problems with the furnace being able to hit 1,000 degrees. When it got to about then, the power draw would drop from about 1.5 kilowatts down to about 1 kilowatt. And after a bit of investigation and fiddling and putting a power meter in line with the plug to measure it more accurately, because previously I was just looking at the graph for the whole house and like, that looked like about the amount of power the furnace should be using, so I guess it's on. But with the plug in line, I knew exactly what this was using. I found out that when it got up to about north of 950 degrees, the total power usage would start to tail off. And after a bit of investigation, I worked out that it was the solid state relay getting too hot to function properly. It was starting to derate, I guess. I found this out by having a air compressor blowing air in the side at the heatsink here, and that brought the temperature down enough for the power to go back up to 1.5 kilowatts, and the temperature started to go above 1,000 degrees Celsius, which is great. I had two options at that point. I could go back to using the big clunky contactor, which is quite loud. I'll give you a demonstration. Clang, so you hear that big bang, you hear that once every 10 seconds when it's cycling below 100% utilization. So once it gets up to temperature, it will start feathering that, and it gets pretty annoying. You know, you can hear it across the house. It's quite loud. Not sure if that comes across on camera. So what I've done is, instead of removing the solid state relay, I'm just using it to drive a big chunky, more modern potted 30 amp 240 volt relay. So it's a little bit of a bodge, but the alternative was I had this relay downstairs in a box. So I could have set up a MOSFET or something to step the microcontroller up to drive a big chunky relay, or I could just use the big MOSFET I already have in the box. So it's a bit awkward, but whatever, it does the job. So the microcontroller drives the solid state relay, the solid state relay drives the big chunky relay, the big chunky relay drives the heating coils. And now it goes up to, I haven't actually ran it up to 1,000 degrees, but when I turn it on, it does the job. So by comparison, let me just set the set point up. Much quieter. It's not quiet, but it's quieter. And I think that'll do me for now. The other benefit, which I've just realised, which I might do as like a little bit of fun, is to rig up the spare switch, the spare pole on the relay here to drive the light on the front. There's a little neon here that I'm not currently using. Maybe. The other thing that I would like to get to the bottom of, but probably can't be bothered, is whether or not this is saturating properly. So I believe inside this there's just a big chunky MOSFET that can handle AC waveform, or some arrangements of MOSFETs. But I'm only driving it from 3.3 volts, and according to the data sheet, that's fine. But there's a little light here on the front that turns on when it's closed circuit on the output, and it's only very faintly glowing, whereas if you drive it at 5 volts, then it's brightly glowing. So it would be interesting to know if it would derate less, like it would be able to maintain the full through current on the output side. Like it's supposed to be able to do 40 amps. It would be interesting to know if it could still do 40 amps if it were driven at 5 volts at those elevated temperatures. But whatever, should be good. Okay, bye-bye.